Hello and welcome back to the lab. Today on the bench we have an HP 3325B synthesized function generator. So I have it on reasonably good authority that these are fairly stable units and are great to have on the bench, albeit a little bit slow, 20 megahertz, 10 megahertz, and 10 kilohertz on the other waveforms. So not the fastest thing on the planet, but being a synthesized function generator, should be relatively stable and good to go. This one's going to need some cleanup. We've got Sharpie right over the display. There's information hiding underneath here. So first thing I'm going to have to do is I'm going to have to spend some elbow grease, and we're going to get all of this, get these stickers off, get it cleaned up, get the Sharpie off, and get it back to a usable unit. So I will work on that. I'm not going to bore you guys with the cleaning process, at least for that part, and then we'll dive into this unit, see if it works, see if it doesn't work. We will experience that together, and we will see what we have to do. If it doesn't work, we'll make it work. If it does work, we'll figure out what we have to do to service it and get it ready for the lab. Well, I promise this is the same unit. As you can see, the markings are still here. I haven't cleaned the wing off yet, but that cleaned up way better than I was hoping, especially the permanent marker that was right here. That came off quite well. So did need a little bit of elbow grease and a little bit of rubbing alcohol. Actually, a little bit stronger than rubbing alcohol, 99%. But this cleaned up amazingly well. Ecstatic about that. I'm going to take this wing off. We're going to get this Sharpie off and go from there. But making great progress in getting this ready for the bench. Okay, ready to pull the top off. And let's see what we have inside. Well, we have some good stuff. This is the synthesis board, which is actually looking pretty good. Don't see anything that I want to do on that board, so we can leave that alone. We have a power supply and a digital board. Those boards I actually want to do something on. And the power supply board is going to be fun to work on because we have pass elements up here. Zoom into that. So we have some pass elements that are heat sunk to the chassis. They go down to the board, so we'll have to pop those out. There is some stuff on here I want to replace. This is getting into the era of equipment where capacitors start tending to be a real problem. Oh, little display. No, wait, dip switches. Dip switches, sorry. That looked like a little LCD display for a second. And I want this to run on the bench for quite some time. So I am going to deboard this, take these boards out, and we're going to do a wholesale capacitor replacement, and we're going to check the voltage on this battery that's hiding underneath this ribbon cable and make sure that's good. That's going to be the RAM battery. This particular unit does have the ovenized crystal in it. It has option 1. And that cap looks like it's seen a little bit better days. So, yeah, this one's going to get a recap while we're in here. So I'll take a bunch of pictures. We'll start working on this, and I'll start getting some boards out, and we will start looking at some capacitors. All right, here is the bottom of the unit, and I'm not seeing anything of concern on the bottom. This is going to be the attenuator block that sometimes has problems in this board. We are going to do the electrolytics on the oscillator card, so that'll need to be done. Here is the option 1 OCXO. That board looks fine. So these two boards, nothing to work, or these three boards, nothing to work on here. Everything looks good. 2 on the bottom on the oscillator that need to be done, and some on the top on the power supply that also need to be done. One of the things I might do, given some future plans, some very near future plans for the lab, I may unplug the crystal from power and disable the internal time base and let this just run on the rubidium, because where I'm going to put this, it's going to be pretty close to the rubidium unit, so I may use that as the time base. I don't want to deinstall this time base. I'm going to let it be here, but if I'm not using that time base and I'm just going to let it be on the RB, I just don't want it burning power, keeping the oven hot. So it would be a simple matter if I ever wanted to use it again, plug the oven in, let it fire up and run. I do have the bridging connector on the back of this one, so might be future plans, not 100% sure, but I have enough stuff plugged in here in the lab that I really need to start watching the power burn, because the power bill's getting kind of nuts. Okay, we have board number 1 out. So first up, let's grab some meter probes, and we'll check this battery. I don't see anything wrong with it. Looks good. So our bateria. Nope, wrong way. Our bateria, 3.1 volts. So that's fine. All right, I will start the obligatory soldering and replacing some capacitors. Okay, let's talk about this thing. Here's my view as I was working on this board. We got a couple capacitors here. Actually, we'll do some cleaning while I'm talking. There is some places where these capacitors get obnoxiously close to traces and vias here and around. So this is definitely a repair that is fairly delicate. It would be very easy to short out some of these vias and a couple of other things while working. But did it need to be done? Well, a couple of the caps, I was kind of spot checking them as I was testing them. This is supposed to be a 220 microfarad by 10 volts. And we're at 284 with an ESR of 0.64. So they're starting to get a little up there. These blue ones are even trickier. These were kind of a pain because on most capacitors they mark the negative side. On these blue ones they mark the positive side. So if you're not really careful, you'll put them in backwards. Almost a half an ohm. Yeah, almost a half an ohm on that one for ESR. So did it absolutely need to be done now? Nah, probably they were good for a little while longer. But I want to get in this unit, get it repaired, get it set for the bench, and get it ready for the long haul. So did it need to be done absolutely right now? Not particularly. Am I glad I'm doing it and it's over? Yep. It's another good idea to do interim testing as you're doing an assembly or things like that. So when you finish an assembly, if it's not too arduous to put the device back together, throw it all back together and see if either the condition improved or broke. Because if something broke, we know we only messed with this board. If I do all the board shotgun, it could be anywhere in the unit, and I'm in for hours of troubleshooting. This will, at least if anything happens to it, we'll know it's this board that's the problem. So I'm going to go ahead and get this thrown back in real fast, and then we'll fire it up and see if it works. Hopefully it gives us some waveforms. Well, sometimes this happens. I got the whole thing back together, and I realized I missed one, so got to take it all back out again. Okay. Once more, the board is in, and everything is good. One thing that is kind of interesting, I'm going to zoom in on this. The board-to-board interconnects in this unit are RCA jacks, so that's kind of different. But it's low frequency, 10 megahertz at most. Okay, let's fire up a scope. And we'll turn this unit on and see if we get some output. I would expect us to, as long as I did my part correctly. Okay, we will bring all of you down to bench level. Let's turn up some speed here. We'll get a nice trace going. You guys will be able to see if any excitement happens. We're set to 0.2, so we'll ask for a volt peak to peak and a sine wave and see what happens. Okay, so we have communication, and the board we fixed is the processor board. The microprocessor started, and everything looks good there. So we'll ask for frequency of 1 kilohertz, and we will ask for an amplitude of 1 volt peak to peak. And we have output. That's AC coupled, left. Trigger source is 1. so we should lock in the trigger here soon. There we go. All right, so nice stable sine wave. Everything looks good. Power supply will be next. So we got to pull that out and take a look at it. But board 1 is repaired. 2 more to go. Well, I was going to do a lot of the work and then just show you guys the results, but sometimes you wonder if you should be being this invasive, things like that. Here's one of the capacitors that's been removed. The board is starting to get a bit crusty. We have to clean this off before the new one goes in. I also found this 6.3 volt. This 6.3 volt capacitor that is testing fine for ESR, but failing leakage. These blue ones around this era were known as computer grade capacitors. Here's the ESR tester. So my ESR's 08, which is okay, but it's registering as 528 microfarads. This is a 470 microfarad capacitor. It's not that it's an overachiever, it's that it's starting to pass DC. So that guy's toast. This 470 by 35, what's he doing? Other than making my board a bit crusty. Nope. He's failed for DC too. So, we're going to get this all cleaned up, and I'm going to get the cap in there. And if there was a question as to whether this work was necessary for this particular unit, the answer is I found enough bad to justify replacing everything to give it the best chance I can in the long run. The one capacitor I'm worried about is this one. This is the original that was in this position, so we've gone from short and a little bit more round to a little bit taller and skinnier. I'm going to have to really check for lid clearance to make sure this isn't touching the lid when I have the unit closed. I think I'm going to make it for height, but it's going to be close, so I may need to get a different capacitor to finish up this build, but this is the only 10,000 microfarad at 25 volt cap that I have. So we're going to run with it. If it works, great. If not, we will get something of the correct physical dimensions. Okay, let's talk about this power board for a little bit, because some stuff just got weird and I had to make some decisions, so this wasn't a 100% straightforward repair. So these two capacitors are these two capacitors right here. Now, I could tell by the tops of these caps, this outer jacket is actually a heat shrink tube, so if these caps get really, really hot, one indication is that the caps got hot is the heat shrink pulls away from the top. And these they're not blown or anything like that, they're not vented, but they did get warm at some point, and I knew that, so that was one of the things that concerned me why I wanted to do the capacitor refresh anyway. But, so I did my tech photos, took a bunch of pictures, things like that, and as I was putting the new capacitors in, I noticed that, because I hadn't swapped this one out yet, but I had swapped this one out, and the polarities were mismatched. And I was like, okay, well, the polarities are the same on the solder mask, so what's going on? Dug into my photos that I took of the board before I started working, and indeed, the caps were put in with the negatives facing this direction instead of this connector. So that doesn't match the silk screen of the board. Now, when doing restorations and things like this, the silk screen is not always 100% accurate. I know there's some tech gear, specifically somewhere in the 2000 series, where a couple of the caps, the silk screen has the polarities reversed. So you do want to bias to what was in circuit at the time. But these caps got hot. They don't test well. This is a 100 microfarad 25 volt capacitor. They test okay for ESR. But they're only half capacitance, actually, and the ESR's starting to get a little high. These were in the 0.06 ohms range for the rest of them. So both of them test very poorly. So they are not 100 microfarad capacitors anymore. So those needed to be changed out. But it didn't appear that anybody had been in this unit before. Knowing where it came from in a government lab, it would be very odd for an entire board would have been swapped out for replacement, at least at this era. So had me scratching my head of going, okay, what's the story with these two caps? So fortunately, I was able to pull up the board number, and there's a whole bunch of pictures online that actually have these two capacitors in circuit in this polarity, which match the silkscreen. So I have photos online and silkscreen that now agree with each other. I have capacitors that were abused, that were in the wrong way. So given those three pieces of information, I'm apt to say these were put in incorrectly from the factory. It doesn't appear that I'm the first person to have a soldering iron on this board other than the assembly. So I guess it was a factory fault, and I'm kind of surprised it was working. So definitely needed to do some work on this board if that wasn't already insanely apparent. Now, not to be confused with these blue caps again, where the line side is actually the positive side on these, not the negative side on these. So, still working around a little bit. So we're going to get this last one swapped out. We'll get it all put back together, and we'll see if we release the magic smoke. Okay, we are all set with the new capacitors. I have triple-checked this board to make sure we replace them all, and we have not. Oh, yeah, we did. Yeah, we did. Yeah, that's a ceramic. Okay, no, those are my pins. So, yeah, we have replaced them all. I was worried about this one right here, but it's 105 degrees C, and everything else was 85 on this board. So we have replaced all the capacitors. So once we put it in place, we won't have to tear it apart again, which will be nice. So let me get the unit back up here. We will throw this back up, and then we're down to one board. All right, now that we have the board in place, let's make sure we're going to have top clearance on the lid. Well, that's going to be good. I got enough clearance. I can fit a screwdriver in there. I thought it was going to be close. It's not even close. So we are good on that capacitor. I'm good to put the bolts in and start hooking stuff up. All right. Let's see if we release the magic smoke. Actually, I want to monitor this, see what it's drawing. Let's hook this up to the powder meter. All right, we're drawing about 10 watts with the crystal heater. That's normal. So the power supply's at least woke up a little bit. This is a linear power supply in this unit. It's not a switching supply, so we have a big transformer. So the board we worked on was regulation and pass elements and things like that. But here we go. No smoke. All right, so the caps were, in fact, in circuit the wrong way. Now, whether that is a technician was in here before me or a factory fault is incredibly hard to tell and unknown, but it is much happier now. Unit's drawing about 70 watts with it on, and everything looks like it's good to go. Yeah, let's do some distortion. 0.3% THD out of a function generator, 0.2%. Not too bad. We are at 1 volt. Let me drop the range to 2 volts. .1%. Actually, this does 10 volts out, so let's, since we're here, why don't we just give it some go. Total harmonic distortion at 10 volts peak to peak. Had a bad switch. Auto range 0.3 or 0.03. Not bad from a function generator. I just realized I forgot to do something. Good thing this is just a data connection on the back panel, so that didn't hurt anything with the testing or the unit. But I did forget to plug a cord in. Be extremely careful doing that. The 110's right here, so my fingers were pretty close to the 110 when I was doing that, so be aware. One kilohertz amplitude, 10 volts, peak to peak. Okay, so that looks really good, and I am absolutely ecstatic with that. One of the reasons this function generator is so valuable is of its incredibly clean waveforms that are coming out of it. So really, really good shape on that one. We're just going to let this cruise, and I'm going to put the cover back on. Actually, I'm going to do the crystal oscillator board next. Okay, the OCXO board was quite quick. We have the two caps replaced. I did beef both of them up in terms of capacity, so we should get a little bit better filtering on this board, and even though they got a little bit bigger, they got smaller. So more capacitance, less volume, always good. Get this reinstalled, and then we'll do some burn-in. All right, we're all set with the crystal back in the unit, so I'm going to put the bottom cover on and just get it ready for its burn-in testing. I have verified, triple-checked that these capacitors are in the right polarity, so we are going to move right into the burn-in phase. I'm going to fire up the Rigol because I don't want to torture one of the tech scope displays having this show a sine wave for hours on end, but the LCD panel will care far less than the CRT. So, yeah, I'm going to get the bottom cover put back on. We'll fire it up. I expect everything to be good. We'll just let it cook for a couple hours. All right, we have a 5-volt sine wave coming out of the function generator. I can adjust its frequency if we would like to. Frequency of 10 kilohertz. Boom. So, ecstatic about that. We're just going to let this thing cook. Drop it back down to 1 kilohertz. So I am super stoked about that. Everything looks good. And just going to let it run on the bench for a while and make sure it goes. The amplitude's pretty good. And then we'll run it through some self-checks. If the self-checks pass, this thing's ready for the lab. All right, it's been quite a while, and I just unplugged the cable. We're going to run it through some self-checks and see what happens. So we shift, self-test. No errors. So this thing's ready for the bench. Thanks for stopping by the lab and taking a look at the restoration on this 3325B synthesized function generator. This is going to go in the bench. We're getting close to the 3,000 subscriber count as this video is being recorded. Not too far away. So I had some plans for the 3,000 subscriber video, but given what's happening and a couple of things around the lab, those plans are going to get shifted around and bobbled around a little bit. So we got some cool stuff coming, of which part of this is going to be part of it. So if you like this kind of content and things like that, hang around. As always, more is on the way. If you'd like a little bit more content, check out the Patreon page. Patrons are running about 5 or 6 videos ahead. I can't remember which at this point, but they are 5 videos ahead of the channel. So there is nothing behind the paywall, so everybody who supports the channel does so to keep videos like this coming for YouTube and to help keep the content as ad-free as I can make it. I can't make it 100% ad-free due to the fact of YouTube itself, but the Patreons do help me support the channel, keeping videos coming, and their support helps far more than anybody knows. So hit all the YouTube buttons, like, share, subscribe, and as always, more is on the way, and I will see everyone in the next video.